Algebra 1, here we go. 10.3, last section we're doing in Chapter 10. Operations with radical expressions. Our essential question today is what properties of real numbers, double bar R, real numbers, can you use to perform operations with radical expressions? You're going to add and subtract them just like, combine the like radicals, just like you do if they were x's or y's or whatever. So how do we do it? Okay. Example, simplify. As long as the radical parts are the same, just add, subtract up the numbers in front of them as if it were x's or y's. Okay? So 6 square root of 11 plus 9 square roots of 11 give you 15 square roots of 11. Remember there's a 1 right here. We don't put it there, but there's a 1 there. It's understood to be there. 1 minus 5 is negative 4 square roots of 3. Okay? As long as the radical parts are the same, we're good. When they're not the same, okay, we look to simplify the radical first, and then we add or subtract. Okay, so in this instance here, you can't subtract these the way they are. Okay, that's the square root of 3, that's the square root of 12. But you can simplify the square root of 12. It's 4 times 3, the square root of 4 is 2, so you get 2 square root of 3. Now you see here you got your square roots of 3, 5 minus 2 is 3, square roots of 3. Okay, so if they're not the same, look to simplify, then you can add or subtract, combine like terms. Alright, so let's take a look here when you multiply. Okay, multiply and simplify. The rule about multiplying is multiply the outside numbers. If there's anything here, remember there's a 1 right there, with anything that's outside, and you multiply the insides with the insides. So here it's just like distributive property. Okay, we're going to take the 1 times 1 on the outside is 1, and 10 times 6 is 60, so we get the square root of 60, plus 3 times 1 is 3, square root of 10. Okay? Don't make it square root of 30 or anything like that. Then check to see, 10, there isn't a perfect square that goes into 10, but 60, let's see, it's what goes into it evenly. 4 go into it, 4 times 15, right? So this becomes 2 square root of 15 plus 3 square root of 10. Okay? You can't do anything else to that, so that's it. You're done. Okay, that's it. Simplified. If you get 2 binomials, then you're going to FOIL. Our first term, square root of 6 times the square root of 6, square root of 36. Multiply the outer terms. You're going to get plus the square root of 18. Remember, they're both inside. 2 times 1 here, negative 2 times 1 when you do the inners. That's negative 2 square root of 18, 3 times 6. And then the last terms, negative 2 times the 1 is negative 2. Square root of 3 is 3 is square root of 9. Okay? So, this is 6. This right here is negative 2 times 3, which is negative 6. So 6 minus 6, that cancels out. And what I'm left with here is 1 minus 2, I get negative square root of 18, which is negative 9 times 2, so I get negative 3 square root of 2. That's my simplified answer right there. Okay? A couple things you got to be careful of here. FOIL, and notice I just wrote it out just the way it would be. I took the square root here. I took the square root of the 9, it's 3. You multiply it by the negative 2, you get negative 6. 6 minus 6 cancels out to 0. 1 minus 2 gives me negative 1, square root of 18. Like terms, just combine them. 18 is 9 times 2. So I get negative, the 3 comes outside, negative 3 with the 2 left inside. Okay? That's multiplying. Very similar to what we've been doing. Just be careful with your radicals. Okay? All right, what is a conjugate? A conjugate is the sum and difference of the same 2 terms. It looks like this. If one term is the square root of 7 plus the square root of 3, its conjugate will be the square root of 7 minus the square root of 3. All you do is you switch the signs in here. Numbers are the same, switch the signs there. Okay? And what you find if you distribute or FOIL like we did up there, square root of 7 times the square root of 7, square root of 49. positive times a negative, negative square root of 21, plus square root of 21, minus the square root of 9. You notice here, boom, they cancel out. And I get square root of 49 is 7, minus the square root of 9, which is 3. The answer is 4. But no more radical, okay? The radicals cancel. It's just one L to cancel. They cancel when you're multiplying the conjugates. So, we use the conjugates to get rid of the radical in the denominator. Remember we were talking earlier about having a radical left down here in an earlier section, I think it was the last section, and how you multiplied the top and the bottom by the same thing so that we can get the perfect square and square root it. Well, to get the radical out of here when there's two of them in here, you multiply by the conjugate. You got a minus here, so you get pluses here. Okay? And it's the same thing over the same thing, so it's 1. So we're not changing any values. So it's going to be 10 times this, so I get 10 square root of 7 plus 10 square root of 2 all over. This right here is going to be the square root of 49, which is 7, plus 14 minus 14, so that cancels out, minus the square root of 4, which is 2, so I get that. So I end up with 10 square root of 7 plus 10 square root of 2 all over 5. And you can put the 5 into both of those. You get 2 square root of 7 plus 2 square root of 2. Okay? You can't combine those because you have different radicals. Alright? But you'll also notice no more radical in the denominator. So we use the conjugates when we get two terms here. Just change the sign. Multiply the top and the bottom by the same thing. Okay? Multiply just like we did up here. And then simplify at the end. Okay? So, add and subtract like radicals, multiplication, and when you get division here and you can't simplify the radical, multiply the top and bottom by the conjugate. You'll get rid of the radical in the denominator, simplify at the end if you can. Okay? We'll look at some more of that tomorrow when we get in class. See you then. Bye.